We in California grow a nation-leading abundance of over 200 crops. These crops, like all plants, need food to grow, including 16 chemical elements, sometimes referred to as nutrients. All crops need especially large amounts of two nutrients: nitrogen and phosphorus. Nitrogen and phosphorus exist in our environment naturally, within minerals and humus in the soil, and in the case of nitrogen, in the atmosphere as well. Nitrogen and phosphorus are also introduced into our environment as fertilizers, in livestock wastes, and when industrial and municipal wastes are discharged. The nitrogen and phosphorus from these natural and man-made sources move through our environment in a continuous cycle. But the nitrogen and phosphorus that nurture our agricultural riches have made their inadvertent way off the fields. Nitrate, a form of nitrogen, has been carried in some of the water that leaches down through the soil to groundwater, and forms of both nitrogen and phosphorus have been carried on particles of eroded soil that flow along in runoff to surface water, all of which degrades the water and causes a number of problems. The heavy use of nitrogen fertilizer and livestock wastes have contributed to an elevated level of nitrate in groundwater in many areas throughout the state. In some areas, the level of nitrate in wells exceeds California's drinking water standard, 45 milligrams per liter. Remedies, including drilling new wells and buying surface water to replace contaminated groundwater, are costly. Our state government paid over $48 million in 1986 alone. Water containing excessive nitrate takes its toll on the health of some of us who drink it, too. Researchers have linked methemoglobinemia, the blue baby syndrome, with drinking water that contains more than 45 milligrams per liter of nitrate. Our livestock, especially cattle, horses, and newborn pigs, may become ill or die if they consume too much nitrate in their feed and water. Irrigating our crops with water that contains a high level of nitrate can contribute to problems that stem from overfertilization, such as sugar beets with a low sugar content. As little as 0.3 milligrams per liter of inorganic nitrogen stimulates the growth of aquatic plants, such as algae, in irrigation water, resulting in plugged pipelines, sprinklers, and valves. Also, nitrogen can be carried with particles of eroded soil to streams, lakes, and rivers, where it can prompt the growth of aquatic plants, eventually degrading water quality. Water with 0.2 milligrams per liter or more of ammonia, another form of nitrogen, is highly toxic to fish. Phosphorus causes problems too. Unlike nitrogen, phosphorus strongly binds to particles of soil or forms compounds that are only slightly soluble in water. This means that phosphorus rarely leaches down to groundwater. It does, though, flow along in runoff on particles of eroded soil or livestock waste to eventually pollute streams, lakes, and rivers. More than 0.05 milligrams per liter of dissolved phosphorus in these streams, lakes, and rivers stimulates the growth of aquatic plants. These plants shade the water's lower depths, where decaying vegetation then begins to consume oxygen. This depletion of oxygen can kill fish. Farms are not the only source of nitrogen and phosphorus. For example, septic tanks are another source. But growers can minimize the amounts of nitrogen and phosphorus that originate from their fertilizers and livestock wastes. The key is proper management. It's helpful as a first step to evaluate how prone your area's groundwater is to contamination by downward seeping nitrate. One decisive factor is the type of soil in your area. If the soil is high in clay or has an underlying layer of material that restricts the flow of water, nitrate-laden water is less likely to leach down through the soil to groundwater. The type of crop is also a factor. If you're growing a shallow-rooted crop like lettuce that uses nitrogen inefficiently, you may need to apply more nitrogen fertilizer than if growing a crop that uses nitrogen efficiently, such as sugar beets. The more fertilizer you need to apply, the more it's likely that nitrate-laden water will leach to groundwater. Your irrigation system's efficiency makes a difference too. An inefficient system, such as a border or furrow system with long runs on coarse soil, results in a lot of seepage, making it more likely that nitrogen will leach down to groundwater. Consider, too, the amount of rainfall in your area. If your area receives a lot of rain in the winter, leaching is more likely to occur. Regardless of the factors that prevail in your area, you must take the same steps to minimize nitrogen pollution. Carefully manage your irrigation system, your use of fertilizer, and your crops. In managing your irrigation system, your goal is to minimize the amount of water used and apply the water as evenly as possible. This will make it less likely that water laden with nutrients will permeate down through the soil to groundwater, and that runoff containing nutrients will wend its way to streams, lakes, and rivers. To achieve this goal, check your soil water content and schedule irrigation accordingly. If yours is a furrow or border system, shorten the length of the runs. Laser level your field if it's uneven. If the field is smooth, the water from irrigation will be more uniformly applied and less of it will leach down to groundwater. You may also benefit by using surge irrigation, that is, irrigate in surges or on and off cycles, and building a tailwater recovery system to collect and reuse the water before it runs off the field. If you use sprinkler irrigation, you can also benefit by replacing worn sprinkler nozzles and placing the sprinkler pipes of a hand-move sprinkler system in different spots each time you irrigate. Changing to a properly designed and operated low-volume system of irrigation, such as drip or microsprinkler, can also reduce the amount of nitrogen carried to groundwater by leaching and to surface water by runoff. In managing your use of fertilizer, your goal is to reduce the amount of nitrogen available for leaching and improve the efficiency of your crop's use of nitrogen. To achieve this, estimate your crop's uptake of nitrogen per acre based on your goals for yield and quality. Then apply only the amount of fertilizer that the crop needs. Using more fertilizer is wasteful and increases the likelihood that nitrate will leach down to the groundwater. To adjust your estimate of the amount of fertilizer required, test the soil before planting to find out how much inorganic nitrogen it contains. Use an accredited laboratory that has experience with your area's conditions. Also, when estimating the nitrogen requirement, remember to take into account the residues of nitrogen in your high nitrogen crops, such as legumes. Take into account the nitrate in your irrigation water, too. Use little or no fertilizer on a small area of your field to monitor your crop's performance. Time fertilizer applications to match your crop's periods of nitrogen uptake. In other words, use small amounts at the outset and place them near the seed. Apply larger amounts later on by side dressing, that is, beside the rows of your crop. Or apply these additional amounts by foliar fertilization. As its name implies, this involves spraying the leaves with fertilizer. Foliar fertilization improves your crop's efficiency in the use of nitrogen and reduces the amount that leaches to groundwater. You can also apply additional amounts via your irrigation system. This is known as fertigation. For maximum effectiveness, apply water uniformly. If you're fertigating with a sprinkler system, fertigate when there's little wind. If you're fertigating with a flood or furrow system, use short runs to promote uniformity. Introduce fertilizer into the system during the middle of the irrigation set not at the beginning, and stop it just before the set ends. This minimizes the amount of nutrient-laden water that leaches beyond the reach of the roots. Use and maintain backflow prevention devices when you inject into pressurized line. Or use a tailwater recovery system. This reduces the amount of nutrient-laden water that runs off. If you're growing a crop that yields a high profit, consider using a slow-release fertilizer. That is, a fertilizer that is coated, slowly soluble, or enclosed in capsules made of a porous membrane. To check how closely your application of fertilizer coincides with your crop's uptake of nitrogen, you might have an accredited laboratory analyze samples of plant tissue from your crop. If you're using manure or compost for fertilizer, apply them conservatively. Design the storage space for your fertilizer so that spilled fertilizer and contaminated rinse water don't come into contact with the soil, where rain can cause nutrients to leach to groundwater. In managing your crops, alternate a deep-rooted crop that efficiently takes up nitrogen from the soil, such as alfalfa, with a shallow-rooted crop that less efficiently recovers nitrogen, such as lettuce. Improve the soil's retention of nitrogen by growing a cover crop in the winter instead of leaving the land fallow. If you're growing almonds or some other perennial crop that needs a lot of nitrogen, grow a cover crop between the rows. Note that this may require you to make other changes in management. To minimize the amount of phosphorus transported from your field to streams and other bodies of surface water, you want to reduce runoff and the amount of soil that's eroded, and manage the wastes of your livestock properly. In some cases, vegetative filter strips can help to remove nutrients from runoff. Fence streams and build crossings. Apply livestock waste to your field according to its value as fertilizer, not according to the amount in need of disposal. For more information on how you can minimize the contamination of water by nitrogen and phosphorus, consult your local cooperative extension or soil conservation service agent. With your consistent use of sound management practices, agricultural productivity and pristine water can coexist in the Golden State for generations to come.